Okay, I'll share. Let's close this. Let's just share the desktop. That's good. All right, let's share the desktop. Dang it, that makes me mad. 901. No, I don't want to join 901.
Yep, you're in the correct section now.
All right, thank you. I am so sorry. I better start over then if you guys missed everything. You missed everything I did so far?
Yeah, we haven't seen anything.
All right. I am so sorry. All right, let's, okay, let's, yeah, you know what? Let's just do it again. Okay, what I'd like you to do is go to the Word file for chapter 7, and then the first table you run into, drop that into an Excel file. Damnation. Okay. So you're telling me I made a perfect landing at the wrong airport, huh? All right, that's my life. All right, so I have the table dropped into Excel, right? All right, and what we wanted to do was find the expected return for stock A. And I'll just, forgive me, I'm going to do this again. The reality is you'd never want to use annual returns. So this is year 1, year 2, year 3. But just for what we're doing today, they're fine. So I'm going to say that the expected return is the average from the past periods. So I'm going to say equals average. So we're expecting to maintain the average. Okay, and I'll give that a couple of decimals. Okay, the next one is the standard deviation. Okay, and you'll see that Excel has several standard deviation functions. And they all start with STDEV. All right, you see all the different possibilities you have? Okay, the big two here are P and S. Okay, P means population. That means that these 3 returns are the only 3 returns this company has ever had. I have all of whatever I'm sampling, or all of whatever I'm working with is all here. There's 100% of them. Well, that's not. This is 3 out of who knows how many possible returns you could have. So we're going to use the sample. And we'll highlight the returns. Okay, and let's go with percent format. Okay, and then the variance is just the standard deviation squared. So we'll go up 1, and we'll square it, caret 2. Give that a percent. All right, and then all 3 of these, let's take them west. Let's go west. And copy them across. That's good. Okay, now the next thing I did, we have to calculate the covariance between each of the pairs. And I was trying to explain that if your covariance is a very high positive number, that means that the 2 stocks, because you only compare 2 at a time, if the covariance is a very high positive number, that means that they follow each other. Like one stock is up, the other one is likely up just about as much. If it's a low number or 0, that means they don't follow each other at all. And if it's a large negative number, then they tend to go exactly the opposite way. Okay, so let's try it. Equals, and then we'll use covar. Yeah, actually, you gotta spell it out. Variance. Oh, my fault. And then again, we have our option of a stock, a sample, or a population. We'll use .s. And then, okay, now this is between pairs. So we're going to do it between A and B, A and C, A and D, and so on. So our first pair is between A and B. So I highlight the range, I highlight the returns for A. And I'm going to lock those. So, F4, function F4 or Command T, depending upon what you're working with. And comma, what other stock are you going to compare this to? Well, I'm going to compare it to B. So I do that. Okay, and then I hit enter. And let's do a percent on that. Okay, now I'll copy that across. So I'll do AC, AD. And then I'm going to do AB, even though it's, or BC, even though it's not going to be correct. And I'll show you what I'll do. So this one is not correct. He should be. So you can just do a little quality control here. Yep, it's between these and these, isn't it? So that's A and D. Okay, this one. So I'm going to double click it and just make it right. So I want this to be between B, and then I'll move this range over to C. I'll take a breath, I'll give you a chance to catch up. And we'll change that one to B and C. Okay, and then copying that one more over, we'll get B and D. Okay, then I need C and D, and I'll just copy it, even though it'll be wrong, very much wrong. I'm going to move this back to here, move this to here. Or you can start over if you'd like, whatever way you want to do it. All right. I am so sorry. I closed 9:01, but apparently it stayed open. So I didn't close it. All right, here we go. 2, 4, 3. Okay, for later analysis, we need averages. So I need to average the variances. I need to average the covariances, and we'll see why later. So right now, let's do an average of the variances. We didn't get that far? We didn't do that, do we? Okay. Average of these 4 right here. And then I want an average of these 6. All right. Okay. So let's go through, and we're going to pretend for a moment you're in a portfolio class. Okay? We're in a portfolio class. And what I'd like to do, I'd like to analyze a portfolio in which I have 25% of my invested funds in each of the 4 stocks. So in other words, that's called an equally weighted portfolio. So if you have 4 stocks, you put 1/4 of your funds in each. If you have 5 stocks, you put 1/5 in each, right? So that's called equally weighted portfolio. So what I'll do, let's come over here. And the first step is to create what's called a covariance matrix. Okay. So the covariance matrix, you'll have a column with each stock in it. So A, or the designator for each stock. That's nice. Don't know my alphabet, do I? C. And then we'll go this way. So a matrix is something which is 2-dimensional or higher. If you have just a row of numbers, that's called a vector. if you have a 2 dimensions, that's a matrix. And you can actually have a, 3 or 4 dimensional matrix, but we don't, that's science fiction, But anyway, so what I want to know is, I'm going to have in here, you know what, we can kind of pretty this up a little bit. Let's go there. Let's center these and underline them. There we go. And maybe we'll take these, give these a right border. You don't have to do this. I just like nicer looking numbers. Okay. So how does stock A, let's center these. How does stock A vary with stock A? How does stock A vary with stock A? Well, that's the variance of A. So when the row and column headings are the same, that's a variance term. So I can do this. I can say equals. I'll go to my variance row, and I'll click on stock A. Do I see that? Okay, so A varies with A. That's the variance of A. All right, now what we'll do, let's save a little bit of time. So do you see how this works? On the diagonal, you're going to have B and B, C and C, D and D, right? Along the diagonal. Does that make sense? So we're going to copy this across, and then we'll fix it. So copy this across, okay? And then I'm going to move this one down to B and B, right? If we go over to here, the variance of B is 6.13%. So I could say B varies with the variance of B varying with B. That's the variance of B. Okay, this will be the variance of C. And this will be the variance of D. So no matter what the size of your matrix is, the terms along the diagonal are your variance terms. Okay, the terms off the diagonal, such as this one or this one, are your covariance terms. So let's get them. So I want A varying with B. So I just go up and get it. Equals the covariance between A and B. So I'm going to find that right here, am I not? I copy that across. Okay, now what you'll find is that, is there any difference between A varying with B and B varying with A? No, identical. So let's do a quick transpose function here. Let's just transpose these last 3 numbers. Or if you want, you can just copy this one to here, this one to here, this one to here, whatever you want to do. We can get away with it. So format painter. Okay, and now let's get another decimal. Okay, then this is C, B with C, B with D. So we have those up here. B with C, B with D. Okay, and then I have B with C. B with C. And I have B with D. So here's B, here's D, right here, right? Okay, do you notice? If you go along, these are symmetrical across the diagonal, right? So this one and this one are the same. This one and this one are the same. So it's symmetrical, right? In fact, we have a function in Excel where we could have just said, give me the covariance matrix, and it would give it to you. The rub is that it gives you half it because it says, well, you already know the bottom half's the same as the top half. It would give you everything above the diagonal and above. But we don't want to do that. So let's get, we got C and D going here. And that would be here. And then we have C and D going here. All right. Let me take a pause. Oops, that didn't work. All right. The cap lock on. Oh well. All right, thank you. Whoever gave me a thumbs up, I appreciate it. All right, let's keep going. All right. This covariance matrix is it will be aiding us in determining what would be the variance or the riskiness of our portfolio if it consisted of some or all of these stocks. Okay, so for example, if I had $100 and I put 100% of it in stock A, and I put 100% of it in stock A, well then what's my variance? Well, it's 1.33%, isn't it? There's no portfolio effects here, are there? Okay, so what we'll be working with is called an equally weighted portfolio. So let's come down and let's repeat this row. Let's copy this row down. Give yourself a couple extras here. That would probably do. You don't need to be that far apart. So let's just copy this. Okay, and then we'll copy these. Now, right above the name of the stock down here, let's put down our investment proportions. So our whole exercise is based upon what's called the equally weighted portfolio, 1/4. So 25% in each of these stocks. And then 25 this way. Okay, so whatever you have here, you also have to have here. Does that make sense? Whatever I have here has to also be the same here. Now, they don't have to be 0.25. Do we get that? They have to add to 1. But they don't have to be. But we're working with a particular portfolio, and that would be the equally weighted one. All right, so how do I find the variance of this stock? So, for example, if I had $100 and I put $25 in each of the 4 stocks, what would be the variance of that portfolio? You see the question we're asking? So what's the variance of an equally weighted portfolio? Right, and the cell values, oh, come on, are equal to, and let's just use X and Y for an example. So we're going to say the weight of the X times the weight of the Y. So if I had 2 stocks, X and Y, times the covariance of X and Y. Okay. So basically, what it amounts to, weight times the covariance from that pair. So let's go back over here. So we know the weights are 2, 5, 2, 5, right? So let's fill in this one. So equals weight of X. So I think of X as the what? Horizontal, and Y is the vertical column. Okay. So the weight of X, this is the first one. So we're going to take the weight of A. Okay, now do you see these 25s are all in the same column, aren't they? So lock the column. So 1, 2, 3 times on F4, 3 times on function F4, 3 times on command T, depending on whatever platform they're using. Oh, I see HP, and that is not one. Is that a Mac? Okay, your command T, you know how to do that, right? Okay. All right, times. Okay, and then we're going to take, so the weight in this column times the weight in this row. So times here, and now what do you think I'll do? Exactly, twice. We're gonna lock just the row, so that's F4 twice, Command T twice, okay, and then multiply it by the covariance between A and A, which is the variance of A, isn't it? And that's what I show. So let's get these into percents if we could. Okay. Now what do we have to do, you think? I bid we can fill this thing out in less than 10 seconds. So you're going to copy this all the way across. And you will copy this down. All right, so let's do a quality check here. So I'll double click this one. So it's 25 times, yep, looks like it's good, doesn't it? So I think we're good. All right. Let's see what our portfolio variance would be. So VAR, variance of the portfolio. And to find the variance of the portfolio, it's absolutely everything in here. Okay, so it's all of these. How do you want to do that? You realize when you do an auto sum, it doesn't have to be a row or a column. It could be a block. Yeah, so we're just going to do an auto sum. I'll click on auto sum, and I'll highlight the whole block. That is the variance of my portfolio. Okay, let's come down. Let's do the standard deviation of my portfolio. Oh, that's different. Okay, let's stay consistent there. That's this, and this is a big two. Okay. And what's that again? It's just the what? So if we took up here, we took the standard deviation and squared it to get the variance. We're going to work that backwards now. We'll take the square root of the variance to find the standard deviation. So we're going to say equals this one, and we'll caret it to the 0.5. Change that to percent. Okay. Now our purpose isn't to worry about returns. That's not what we're doing today. Our goal is to find the limits of diversification. Okay? That's risk, not return. But if we wanted to, let's just see what the return of this portfolio is. Return on the portfolio. Okay? So I'm going to say equals sum product. Sum product. Okay, so I have 25% of my funds in each one of these stocks. So I'll highlight the weights, comma. Now what this function does, you give it two ranges and it multiplies the first number in the first range times the first number in the second range, second number in the first range times the second number in the second range, and then it adds it all up together for you. Okay? So what I'm basically doing, what am I doing here? I'm going to take 25% of 9%, 25% of 21%, and so on. So I just highlight the second range. Okay, and it should say 14% unless I did something wrong. Oh, it looks pretty good. Okay, but that's not what we want. Now let me bring up something else you might have done. What if in your you're going to take investments eventually? Anybody in investments? Okay. You did betas sometime. I'm sure you're sick of betas. How do you calculate a beta? You take the covariance between the market and the S&P 500, for example, divided by the variance of the S&P 500. So variance between the stock and the index, covariance between the stock and the index divided by the variance of the index, right? Something like that? Well, you do. Anyway, okay, that's the way we do it. That's practical. Okay? But here's how you'd really do it if you had the data. And I'm going to show you why you probably don't have the data. how you'd really do it is I'm going to say that the contribution to this portfolio's risk from stock D is all of these. I have its variance, I have its covariance with the other cells, so I'm going to add this across. What you got in the cell phone there is so important. Hate to have you miss a hot date from my class, but nonetheless. So 2.31%. Okay, and if I copy that all the way up, okay, so the A stock contributes this much to the total. The B stock contributes this much to the total. Okay, so if I were, get this out of the way, if I were theoretically calculating a beta, it's the stock's contribution to the portfolio risk divided by the total risk of the portfolio. So here's our estimated betas then. We're going to say equals this one divided by the total. So 12.41% of the total, 0.3831%. Now lock the total there if you would. Of course. Excel has to do that, doesn't it? Don't know why. All right, get back. All right. Now I'll do that for all four. I'll copy this down. And if you look, so these are my betas. And actually, you know, I guess you usually see betas as fractions, don't you? Yeah, so these would be my betas. And if you do it right, the betas all end up summing to 1, right? Remember you have this thing in your betas. What's the beta of the market? What's the beta of the market? It's always 1, isn't it? Right? So, what's wrong with this? Why don't we do this? Well, let's just look at it for a minute. What if you have, now, in a population with 4 stocks, this is exactly what I would do. This all we had is 4 stocks. Let's give ourselves 6,000 stocks. I don't know the number, to be honest with you. It's got to be something like that. 6,000, the Wilshire 5,000, I mean, that's 5,000 right there. Anyway, 6,000 times, let's just say 6,000. Okay. And, you know, if you show that with commas, oops. Okay, so this matrix for 6,000 stocks has 36 million cells. You see how practical it would be to try to pull something off like this with 36 million cells? Won't happen, will it? So what do we do instead? Well, instead, we take something like the returns on the S&P 500, we call that the market, and then we do the covariance between one stock and the S&P 500, and then we just get by. But this is theoretically how you do it. Okay, let's move along. Where you see this, let's recopy our headings again, if we could. Come on. Okay, and let's recopy these. All right, and I'm going to go back, and every place, okay, here we go. You got a covariance matrix up here, right? Okay, every place you have a variance term. So how many of those are there? That's this one, this one, this one, and this one. So every place you have a variance term, we will substitute the average variance. Okay, so let's come down here. I'm going to say equals, and I'm going to go up and get that average variance term. And we have 2.52%. And you might as well lock that. I don't have to, but whatever. Okay, so every place I have a variance term in this matrix, I am substituting the average variance. All right. If I'd like to treat the covariance in a similar way, what would I do with those? For every cell that's a covariance, you will substitute the average covariance. Let's substitute the average covariance. Equals, and I'll go up and get it up here. So minus negative 328, right? And I might lock that one too. It's not going to change, obviously. All right, so I have all of these are covariance terms. These are covariance terms. This is a covariance term. All right. And then well, that didn't work. Oh, I see what I did. My fault. There we go. Okay. All right, I'm full up now, I think. Okay, so every place I have a variance term, it says 252. Every place I have a covariance term, it says negative 328, right? So now I'm going to repeat. This matrix substitutes for this one. So we're going to treat everything we did to this matrix, we're going to do the same to this other one. So let's come down below. Let's copy your headings again. Give yourself a couple of rows here between. Okay, let's copy our headings here. All right, and we will still use the 25% weights. So we're just doing everything we did up here. And I don't know, you can do it any way you want, but just get them in there somehow. Okay, so we'll do 25 here, and then we'll do 0.25 here. All right. All right, so how did we get this portfolio? We took the weight of the row times the weight of the column times the covariance matrix number for that cell, right? So let's do it again. Equals weight, and what do I have to lock here? The column, right? 1, 2, 3, times the weight, lock the row, times, go up here and get this. All right, so let's make percentages out of this if we could. So I weight times covariance. Copy that across. Copy it down. Okay, so here we go. Portfolio variance. Okay, let's get it. Auto sum. Everything in here. Standard deviation. And we'll take the square root of that number. Express it as a percent. And I hope this is why we did all this. So can you see, in the case of the equally weighted portfolio, that I can work with the averages just as well as I can with the individual pairs, can I? Does that make sense? All right. Did we have to go through all this? Well, I'm just introducing the concept to you. But here, let's do a little quicker version of it. How many variance cells do I have? We know they're all the same, right? So I have 4 variance cells. So I'm going to say equals 4 times, and pick any one of the 4. So maybe this one. Okay. I have 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 covariance terms. And they're all the same. So let's equals 12 times, and take any one of them. Oh, too many. Okay, good enough. All right, if I add these together, so this is 4 variance cells, 12 covariance cells, and then this is 16 total cells. All right, and so this is the portfolio variance, or this is. The variance of the portfolio. Okay, we'll take the square root of this number. And this is the standard deviation of the portfolio. Okay. My point is, can you see that those are the exact same numbers that we've had all the way along? No matter which way we do it, we get these two numbers, right? Okay, now we're going to go to the general case. N has been 4, hasn't it? What if N were 100? What if N were 50? What if N were, see it? So let's just start again. Let's go to the general case. The general case. How many variance cells do we have in general? I have a 100 stock portfolio. How many variance cells do I have? 100. We had 4 stocks here. We had 4 variance cells, didn't we? So what's in general? Can we just call that N? Let's give us a right gist. Okay, so that's capital N. How many covariance cells? Okay, well, we had a total of 16 cells. 12 were covariance, 4 were variance. So what you actually did, you said it was N times, so 4 times 4, N times N, minus N. Okay. All right. What's in each one of these cells? Okay. So variance, so what's in each one of the cells? Okay, for the variance terms, we had 1 divided by N. Okay, let's see, did we do that? What do we have right here? So we have 1 divided by N times 1 divided by N times the average variance. 1 divided by N times 1 divided by N times the average variance. Okay, what do you have here? You have 1 divided by n. Actually, it's pretty close, isn't it? What changes? Instead of the average variance, you multiply it times covariance. Very good, very good, very good. Covar. Oops. Covar. Okay. All right. So let's multiply across here. What do we get? If you multiply the number of terms times what's in each one of the cells, what do you get over here? Product. So I'm going to take n times 1 over n squared times the average variance. Okay, so 1 over n times 1 over n, that's 1 over n squared, times n, just gives you 1 over n. 1 over n times the average variance. Let's write it very simply. Divided by n. Okay, this is a little more difficult. So we are n squared minus n times basically 1 over n squared here, right? So 1 over n squared times n squared. So the first term just comes out 1, doesn't it? Okay, and then we're minus n divided by 1 over n squared. So that's going to leave you with 1 over n. Okay, and then times. Sorry. Oh, yeah, that's right. Yeah. Times the, oops, average covariance. So, nice, succinct little equation. Portfolio, variance, equally weighted. Make sure you just say variance, maybe that'd be better. Equally weighted portfolio. Equals average variance. All right, it didn't work. Average variance divided by n plus this 1 divided by n times average covariance. Okay. And then the same portfolio. Deviation would equal what? Just take the same equation, take the square root, right? Take the square root of this. There you go. All right. So I have your assignment is. Oh, okay. Let's do another thing. Let me go show you how this. You're not going to get average variance and average covariance in your assignment. They're not going to tell you that. Okay. So obviously, what do I need here? I need n, average variance, average covariance. I can work any of these, right? They're not going to give you that. So here's what they're going to give you. They're going to give you, you'll get n will be given. They're going to give you the average standard deviation. Okay, let's say the average standard deviation is, say, let's use an example. Let's say it's 30%. But I think that graph we have looks like it's about, for one stock, is about 30%. Average standard deviation. Okay, so how do you think you get the average variance then? You square it. So they're going to give you an average standard deviation. You square that, you're going to get the average variance. All right. Now, they will not give you covariance. Your authors will give you they'll call it typical or average or something to that effect. They're going to give you a correlation value. And so let's see how you find correlation. Well, correlation is equal to, and it's usually correlation is between some pair. So the correlation between stock X and stock Y is equal to the covariance of the pair divided by the product of the standard deviations. Oops, ready to capture that. I would use that. Standard deviation X times, that's nice, times the and do we have to close that? Yes, we do. Let's make that cap. All right. That's what they're going to give you. They're going to give you the correlation. All right. I want to get I need the average covariance out of this. So we solve for covariance. Okay. And every place you see something, substitute the average. Okay. So the covariance, what we're going to do then, we're going to say equals okay, so if I solve that for covariance, I think you can see it's the standard deviation of X times the standard deviation of Y times the correlation. So we're going to solve for covariance. We're going to say it's the average correlation times, now it would be the standard deviation of X times the standard deviation of Y, but we don't have those. We have averages. Just substitute. Place you would normally have an individual stock, substitute the average. Okay. All right, so let's keep going. Let's say that the average average correlation is, let's say, your authors mentioned 60% about. So let's use 0.6. So from this, let's get the numbers that we need. So first of all, we need the average. We got the average variance already, so we're good on that. Let's do the average covariance. Okay. That would equal the average correlation times, now you could do it either way. We can take the products of the average standard deviation, or we can just take the average variance. But technically, it's the standard deviation of A times the standard deviation of B, and we're substituting average instead of the individual ones, right? Okay, so that's what you get. All right, and let's, okay, we'll keep the correlation as a fraction. Let's give the variance a percentage. That's one wrong way. All right, let's do some portfolios. So N, you have to have at least 2 stocks to make a portfolio, don't you? So let's go to 10. Let's go to 40. Let's go to 100. Let's go to 1,000. Let's go to 10,000. And let's go to infinite. Infinite. All right. So that's over here. let's calculate the average. Let's do the portfolio standard deviation. Okay, here we go. And so, remember how we're going to do it? Let's just put a reminder here. Average variance divided by n plus 1 minus 1 over n times average COVAR and we'll take the square root of that. Okay, so we'll fill it in. Here we go. Equals average variance. We have that. Okay, now do you notice that will not change throughout, will it? So we lock it. Divided by n. Now, n will be changing, won't it? Plus 1 minus 1 divided by m times the average covariance. And so that would be right here, and you want to lock that. Take the square root of the whole thing. All right, let's see how we're doing here. Okay. How are we doing out there? Everybody keeping up? Okay, sounds good. Thank you. 2, 3, 4. Oh man, we're doing great. Okay, so let's continue. All right, now once I have this one, I'm going to copy these all the way down. Obviously, I can't work with a literal string of characters called infinite, can I? Okay, so let's come down. Now you notice, if we did just a real quick here, let's see how much risk we're reducing each time we go up. Each time we go up. Oh, I went the wrong way. My fault. Equals. So we started 2683 and we decreased that to 24. Okay, so we're down 283. Now watch what happens to this. It gets less. It gets less. It gets less. It gets even less. See that? So we are approaching that bottom number now. And you can see if I put 100,000 stocks, it wouldn't change that much, would it? So we're pretty much there at 10,000. But technically, you have to go all the way to infinity. All right, let's go back up. In fact, we don't have to go anywhere. This equation right here. All right, I know we can't touch, feel, or think about infinity, but we can get close to it by, say, 1,000,000, can't we? Okay, what would happen to this first term here if I took the average variance and divided by, say, 10 million? What happens to it? Might as well be 0, right? Does that make sense? Take some small percentage divided by 10 million. So it's not infinity, but it's pretty close. Yeah, it's out there. Okay, now we go over here. What happens? 1 minus 1 over that infinite number. So this term goes to 1. And then I have the average covariance. So this first term is completely gone. The second one just leaves me the average covariance, the square root. Okay, so if I have an infinite number of stocks, that's called a fully, they won't say that in your book, they'll say a fully diversified portfolio. The fully diversified portfolio has nothing remaining but market risk. Nothing but market risk. Okay, and it's just equal to the average covariance and the square root of it. Now there at 10,000? Well, you're not a whole long ways off. I'm gonna give these some zeros so you can kind of see the difference. See that? So you're not quite there, but you're not far off, are you? And what's my reduction thing here come out to be? Won't be much. Oh, doesn't read yet. All right, let's get some more on this one. There you go. So 0008%. Next to nothing. Okay, so everything I did today is in your book, chapter 7. It's the absolute best chapter in this book. You know, back when I was in the Navy, you know, and the ships were made of wood and the men were made of steel, then I got out and went right to school. And when I went to school, I had the same book, only it didn't say 12th edition. It just said book. So I had the very first edition of this I learned from. And I actually think that chapter was better. They've revised it now, and I don't think it's as good, but it's still not bad. All right, if you were on page 179 and 180, we did everything I just did. Okay, not with an example of numbers, but just boxes, you know. But here, but now let me read you on 180. Notice that as n increases, the portfolio variance steadily approaches the average covariance. Isn't that what we just did? Just did that. If the average covariance were 0, it would be possible to eliminate all risk by holding a sufficient number of securities. Unfortunately, common stocks move together, not independently. Thus, most of the stocks that an investor can actually buy are tied together in a web of positive covariances. So, like our example, we said about 0.6, didn't we? Okay, and that's probably not all that far off. Okay, and then let's see. Positive covariances that set the limit to the benefits of diversification. Now we can understand the precise meaning of the market risk portrayed in figure 711. Well, his figure 711 is this one. So he's saying now we can, so this is the same as 711. And he says, now we can understand the precise meaning of the market risk portrayed in, right there. So that's all this. So that's this number right here. We're looking for that number. And it is the average covariance that constitutes the bedrock of risk remaining after diversification has done its work. That's as low as you can go. So in terms of your assignment, you have 2 problems to do. And I think at least one of them, maybe both of them, ask you what's the standard deviation of a fully diversified portfolio. That's what we just did. It's the square root of the covariance, average covariance. That's all you got to do. Okay, so this fully diversified. And let's make a note there maybe. The square root of the average covariance. That's what fully diversified means. That's as low as you can go. All right. He kind of goes in his here. He's talking about the NASDAQ. 5,000 companies listed in the NASDAQ, and he says he has 25. I use 6,000. He used 5. He says there's 25 million boxes, so you can't really do what we just did. That's why we don't do it that way. For finding the beta of the stock, you don't do it that way. Impossible. So anyway, that's all there's to it. 2 problems. If you understand what we did here, you get right through them. They're both the same kind of a thing. You've done everything that you need to know for that assignment, everything. So, let's get out of here. Let's see if we've got any last minute questions in Neverland.
I have a question.
Yeah.
Can you explain why did you, when you were in those charts that we did, why did you lock them a certain number of times? It's like the number of columns and number of rows. Like when you lock 3 times and when you lock twice.
Okay, well, I'm just locking one thing. It depends on, do I want to lock the cell? That's 1 time on F4. Do I want to lock the row? That's 2 taps. Do I want to lock just the column? That's 3 taps. Yeah, because I have some things I do like in my other class where we fill out huge tables and you have to use the same row and column head, numbers to fill out the table. Yeah, so 1 time cell, twice row, 3 times column. And yeah, I'm in your command T, of course. Yeah, I hope it works. Does that work?
Yeah.
Okay. It's kind of interesting. I have people who've taken the class before come in with, I'm pretty sure, the same Apple they used in high school. And nothing worked. I mean, nothing. In fact, I have another class where we'll do Excel files that have 100 rows in them, okay, and filled. And we have an exercise where we would do something that's called either maximizing or minimizing. I had this poor young man sitting over there, and I went over to his desk, and back when you have to do this crap, and he had it set up perfectly. I could not find an error. So I said to him, would you mail that to me, email it to me? He attached it to an email. I used this computer right here. I downloaded exactly what he had, didn't touch it, hit run, and it was perfect. And the only thing we did differently was he had an Apple, and I'm pretty sure it's the same one he had in high school. So now one little problem, none of us have this problem, okay? And I can't verify this at all. But I had just a sneaky hunch, it's just a hunch, that in foreign countries, you might not have an authentic copy of Apple OS on an Apple computer. Because I find that when I run into these very strong difficulties, it's usually with a foreign student. And I just have a sneaky hunch that in many cases they don't have a valid OS on that machine. That's just a hunch. I don't know. Otherwise, how can you explain why doesn't it work? So, anyway, we'll do it again next week.